Hello! Today we are demonstrating our latest product offering, DefleX Edu, from our optical extensometry range. This digital image correlation, or DIC system, is a student-friendly solution for non-contact measurement and visualization of deformations, strains, and displacements in materials. It is an ideal teaching aid for structures and material testing for a range of engineering courses. DefleX Edu offers a student-friendly solution to virtually see how materials behave while being subjected to various loads. It is equipped with camera measurement and image processing software for analysing motions, displacements and strains. It can measure visible features on objects and material surfaces like screws, joints, edges, grooves and composite structures. This is accomplished with the aid of a Speckle pattern applied to the relevant parts of the target surface area. More on this subject later. Versatile in application, the DIC unit is suitable for uniaxial testing, biaxial testing, shear testing, as well as 3-point and 4-point bending and torsion testing, making it a comprehensive tool for material and structural analysis. Utilizing a technique known as digital image correlation, in which a camera records footage of an object/structure under load, the software uses virtual sensors/probes to track changes to the shape and size of unique features on the object. This is then used to determine deflection, displacement and strains on the object. This data can then be visualized in the software in the form of vectors and color maps, allowing students to physically see the processes taking place in real time. This is especially useful in the visualizing processes that must normally be inferred, such as bending moments on a beam under load. DefleX is a versatile device for many kinds of tests and is a great first step into the world of optical extensometers and DIC. When purchased, you are provided with a camera system, a 12mm lens, a USB flash drive, black screen, light mounting arm, 2 LED lights, camera tripod, black and white marker pens, and 2 DefleX calibration grids. There is the option to purchase the additional 6 lenses, which optimizes accuracy. To use DefleX, use the 1/4" threaded hole to attach the unit on a tripod, or use the 2 M6 screws for mounting. Plug in all the cables and connect the apparatus to the electrical supply. Set up your desired experiment and place the camera at the desired distance. Further information on optimal distances can be found in the user guide. For the camera to work properly, the system needs to be well focused, and the aperture needs to be set according to the lighting conditions. Onto the lens itself, there are 2 rings on the lens. The outer ring adjusts the focus, and the inner adjusts aperture. There are 2 locking screws, one for each ring, to lock the position. For the camera to detect movement in the specimen being examined, it is necessary for the surface to be covered in a high contrast pattern. This creates a unique feature in the image for the software to track. Suitable unique features like grooves and screws, for example, don't need a Speckle pattern added. The usage of the pattern will depend on the experiment and the specimen, and the pattern can be applied with the markers provided. The DefleX Edu software will need to be downloaded onto a suitable computer. The software and drives can be found on the USB flash drive provided. When logged into the system, you will be able to calibrate, test, and analyze your experiment. Calibrating the system is essential to be able to measure anything. Calibration tells the camera the scale of the specimen, the distance to the specimen, and the specimen's orientation and positioning. The software reads the dotted pattern from the grid and calculates the distance between each point in pixels. With the real distance set by the user, the grid unit distance, the system can then calculate a pixel to millimeter ratio. On to performing a grid calibration. Select the 2D calibrations, click on the yellow plus button to add a new calibration and select full calibration. Next, name the calibration, set the units used, and insert the grid unit distance. On the next page, the grid needs to be detected to establish a coordination system and a pixel to millimeter ratio. Focus the lens on the specimen. Place the grid flush with the specimen in front of the camera, covering as much of the field of view as possible. Set the specimen thickness and the grid thickness, and then press Detect Grid. The grid should be detected by the system, and the colorization of the grid indicates that it's been detected correctly. Click Finish to complete the calibration. After successful system calibration, you will need to create a measurement method. In the Methods menu, select 2D or 3D in the Real-Time tab, and click on the yellow plus icon to add a new method. Select Flat Specimen, Round Specimen, or Distance to Measuring Plane, and click on the green Area of Interest, or AOI, selection button to drag the green rectangle to cover both the specimen and the area where it's expected to move to. Click Finish and the system will go straight to the method itself. To recap, Prepare the specimen, fit the specimen to the TecQuipment product being used for the experiment being performed, ensure that the required DefleX lens is fitted, set the lens focus and aperture, calibrate the DefleX software, create a method for performing the experiment, and run the experiment. So what we have here is a deflection of beams and cantilevers experiment, or STS4. We have set up a DTI meter measuring the deflection at the centre of the bar. As the bar provided with this experiment has no unique features, you can see we've added a speckle pattern so the camera can detect its movements. First thing to do is to set up a point probe on the point where the specimen connects to the DTI meter. This allows us to measure the same displacement that is being measured by the DTI meter. This point probe will track the point that it is attached to throughout the footage, and a vector can be applied to the probe to visualize the displacement that occurs. After selecting start, a load can be applied to the beam, and you can validate the displacement with the probe by looking at the DTI meter and seeing that the values agree. That's not the only thing possible though. Bend lines can be added. A bend line is a line that's split into equal length segments, and each point acts as a point probe tracking a single part of the image. If a weight is placed on one side of the DTI meter, there is an unsymmetrical load, and if two weights are placed either side of the DTI meter, there is a symmetrical load. This displacement is nicely visualized with vectors. All the measurements so far have been in real time. But an advantage of DefleX is the ability to record live footage and perform analysis later. There are two different modes, playback and post-process. Playback stores the footage locally in the software for immediate rewatching after recording. This enables the user to see if all relevant data has been gathered. Whereas post-process records the footage and then saves it directly to the computer file system. In doing this, the system will then prompt for a file name, and then we select the PP icon to enter the post-process mode. You can then apply as many probes as you like to your recording. Once the desired probes are selected, press compute and the software will recalculate the results and collect that data instead. All the data collected can then be exported into Excel for further analysis. DefleX is an accurate, non-contact solution for strain analysis perfect for short laboratory sessions or lectures with a record once, analyze whenever, wherever feature. The very visual nature of the software and the ability to prep the footage beforehand makes it an ideal tool for concept demonstration in lectures, for instance. It is a great tool for visual learners and teaches students about the DIC technique. We have sample data for several products in the next generation structures, material testing and properties, and theory of machines product lines. A full list of compatible products can be found in the description box below. So, whether you're an educator looking to revolutionize your teaching methods, or a lecturer eager to create interactive and engaging lessons, DefleX Edu is the visualization tool you've been searching for. Contact us today to find out more. Thanks for watching our video. Be sure to like, subscribe, and hit that notification bell for more exciting videos from us.